A further development of this design was the hollow pit and two explosive lenses. A hollow sphere of subcritical plutonium is surrounded with a thick tamper of U-235, which is itself surrounded with high explosives. This, in turn, is surrounded by a lens-shaped initiating explosive with a detonator at each end. A much simpler, smaller design, but one with a highly efficient pit and much better yield. The next development was the use of another nuclear reaction, fusion. Two light nuclei are compressed together under great heat and energy, fusing to form a new, larger element. In so doing, they release more energy and neutron radiation. Isotopes of hydrogen, the lightest of all elements, are used. As in the fusion process of the Sun, the hydrogen is fused into helium. A 50-50 mix of the hydrogen isotope gases tritium and deuterium gas was introduced into the hollow pit of the plutonium. On detonation, the gas would fuse into helium under the heat and pressure of the fission process, thus releasing many more neutrons to boost the plutonium fission chain reaction. This allowed for a quicker chain reaction, needing less high explosive to hold the critical mass together and allowing the removal of the thick uranium tamper. Lightweight beryllium was used as the neutron reflector instead. This design was tested in 1951's Operation Greenhouse and gave yields of up to 45.5 kilotons with a much smaller warhead. The United States thought they had a few years' grace as the world's only nuclear power. But the Americans were shocked when the Soviet Union detonated a nuclear bomb known as Joe-1 on August 29, 1949. Thanks in part to spy Klaus Fuchs, who had been passing on secrets to the Soviets since 1945, their first device was identical to the US bomb dropped on Nagasaki. It would be a further 3 years before the Soviets could detonate a homegrown weapon. The Buster Jangle series in Nevada in 1951, 7 blasts in all, many with troops on the ground, looked at the capability of soldiers to deal with a tactical nuclear strike.
The tremendous detonation, felt 260 miles away, shakes the earth under the soldiers, and the blast fills the air with flying dust. The test is a terrifying experience, but it shows that the atom bomb can be used in support of troops.
Now that the US had to contend with a nuclear-armed foe at the other end of the socioeconomic spectrum, civil defense became a major concern among the population. The government tried to ease fears of red aggressors by releasing several handy films on self-protection from the nuclear threat, all highlighting sensible action to be taken during a nuclear attack.
Every one of us must remember to do the same thing. That's what this film is all about. Duck and cover. We all know the atomic bomb is very dangerous. Since it may be used against us, we must get ready for it, just as we are ready for many other dangers that are around us all the time. You know the places marked with the S sign? They're safe places to go when you hear the alarm. If there is a warning, you will hear it before the bomb explodes. But sometimes, and this is very, very important, sometimes the bomb might explode without any warning. Then the first thing we would know about it would be the flash. And that means duck and cover fast, wherever you are. There's no time to look around or wait. Be like Bert. When there is a flash, duck and cover, and do it fast.
1952 saw the United Kingdom test its first atomic weapon in Operation Hurricane. Britain tested a total of 45 weapons in Australia and some in the US.
Photographed from 13 miles away, the familiar atomic mushroom pours its deadly cloud of radioactive vapor toward the sky.
The Tumbler Snapper series of tests, a total of 7 above-ground detonations, introduced new designs including boosted warheads. In 1952, on the Pacific Proving Ground, Mike, the first so-called hydrogen bomb, is test-fired.
And the United States set off the most awesome weapon of all, the hydrogen bomb. The searing atomic blasts punctuated an event-packed year, a year of which historians of the future may well say, it was a year of destiny.
The fission bomb can give a yield of up to hundreds of kilotons, but increasing the yield even further into the megaton range required a secondary or add-on fusion component. The famous Edward Teller and Stanislav Ulam, two key nuclear scientists, solved the design problem in 1951, as demonstrated by the Mike shot during Operation Ivy at Enwitok in the Pacific a year later with a 10.4 megaton detonation. The radiation implosion harnesses the X-ray energy of an exploding fission bomb to compress and superheat a hydrogen isotope source bonded within the metal lithium deuteride. In a very short time, the hydrogen isotope is released from the metal and fused into helium nuclei, which release vast amounts of energy. The first design consisted of a hollow cylinder of low-cost U-238 surrounding a hollow cylinder of lithium deuteride. In the center of the flute, as it was known, was the fissile trigger of either plutonium or U-235. The flute was 59 centimeters long with a diameter of 38 centimeters, all encased in polystyrene foam. The primary fission weapon is detonated. The massive X-ray energy turns the polystyrene into high temperature and pressure plasma. The plasma compresses the flute and superheats it. This forms the hydrogen element, which begins to fuse into hydrogen, releasing still more neutrons that cause the spark plug in the center to fission almost completely. This releases yet more neutrons and X-ray energy sufficient to cause the relatively inert tamper of U-235 to fission, releasing most of the destructive force of the entire device. Although the fusion process of hydrogen is part of the overall device, it is in fact the fission process that generates most of the destructive force.
The gun crew moves back to take positions in slip trenches during firing. The time is 08:30.
With the reduction in size of the basic weapon, artillery piece-sized bombs are tested at the Nevada test site. 11 detonations with Atomic Annie.
Accuracy 4 times greater than any gun developed before World War II. The 280-millimeter gun has proven...
In August of the same year, the Soviets tested their fourth nuclear device.
13 miles under any weather conditions.
In 1954, 6 detonations, codenamed Castle, were made in the Pacific using deployable warheads. One test of a thermonuclear device yielded twice the expected power, contaminating a large area of the Pacific Ocean with fallout.
100-inch camera is...
Teapot was the code name for 14 more 1955 detonations, this time of devices designed at the Lawrence Livermore National Laboratory.
The familiar mushroom cloud snakes skyward, hurling the atom's deadly radiation high into the heavens.